The Horizon 2020 IMPAQT project brings together a group of international experts with the objective to develop and demonstrate an intelligent technological platform for the sustainable management of an integrated multi-trophic aquaculture farm. The platform is to cover multiple production environments, from freshwater inland farms to coastal and offshore marine farms. The platform is being developed and validated within the project. It is utilizing data from a variety of different data sources, such as current off-the-shelf sensors, novel sensors developed within the project, novel crowdsourced data, laboratory data, remote satellite data, and data from external sources such as apps, and including models. This data is processed to provide intelligent contextual feedback to the operator and to inform decision-making on the farm. The project is a collaboration of 21 multidisciplinary international partners. The consortium consists of 14 academic or research organizations working with 4 SMEs and 3 large industrial partners. Partners span the whole of Europe and include aquaculture experts from China. The partners are all leaders in their respective fields. Expertise in the project ranges from sensors and remote sensing to modeling, AI, and data analytics, to food safety and environmental sustainability. There are 6 aquaculture pilot sites involved in the trial and validation of the project outputs. While globally, aquaculture has been the fastest growing animal food production sector in recent decades, this is not reflected in EU production, which represents only about 2% of global aquaculture production. The EU is keen to change this and have invested significantly in supporting the sector and in the eco-intensification of production systems. There is currently a growing demand for increased sustainability and circularity in industrial processes and in production in general, and this is also an aim in the aquaculture sector. The European Green Deal promotes a transition to a circular economy and economic decoupling, which aims to achieve economic growth while preserving a healthy environment. IMTA is recognised as a tool to help achieve this in the aquaculture sector. The IMPAQT project is working to validate the IMTA concept as a farming concept. IMTA is a fresh concept in aquaculture where multiple species from different levels of the food chain are farmed on the same site or within the vicinity of each other in an integrated and complementary way. The waste product by the fish or the fed species can be utilized as a feed or fertilizer for other species such as shellfish and seaweed, thus lowering the nutrient load in the water and allowing a more circular and sustainable approach to farming. IMTA provides a bioremediation value by reducing the impact of fed aquaculture on the environment. While IMTA provides a diversity of product and an increase in biomass production and benefits to cash flow within the farm with different product life cycles, the key benefits of IMTA are more than the direct economic benefits. The intrinsic benefit on an ecosystem level needs to be considered. IMTA offers greater social, marketing, and environmental benefits. Currently, the cost of waste from monoculture is external to a business. But with a greater focus on minimization of impact, this cost may become internalized through regulation, and this will make the bioremediation element of IMTA more tangible in the business model. IMTA allows the production of a greater biomass of product from a site while reducing the environmental impacts, closing the circularity, and providing diversity in product and economic streams. IMTA can also be considered holistically at a greater than the individual site level. The nutrient balance within a biological area or bay facilitates the planning of IMTA systems as a way to balance aquaculture on a wider ecosystem. Concepts such as nutrient offsetting and nutrient trading can be facilitated within the IMTA model. Integrated aquaculture is considered a mitigation approach against the excess nutrients or organic matter generated by intensive aquaculture activities, and it strongly aligns with the principles of circularity, where waste from one process is reused as inputs to another. The challenges of operating and regulating multi-species sites is a current barrier for the progression of IMTA. As yet, IMTA is not widely adapted at a commercial level in Europe, and understanding the validity of this approach, the interactions of the trophic levels, and the management of IMTA systems is at the heart of the IMPAQT project. The project is working in 3 key areas: an autonomous data acquisition and communication system, an advanced IMTA model, and the integrated management platform. These combine to form a management structure for a complete holistic system view. In IMPAQT, IMTA models for 2 differing farm setups and different environments were developed to run a set of scenarios estimating the benefit of IMTA in the setup of the farms in terms of seafood production and environmental impacts. These models were used to distill a generically applicable blueprint that can be used by others as a template. The models demonstrate the different responses and interactions between IMTA farm components and their footprint on the environment in both nutrient-rich and nutrient-poor situations. The models are valuable research tools to get more insight in how ecosystems react to aquaculture and to assess the response of individual species to an increase in competition or food availability. They can ultimately be useful tools to investigate the potential of IMTA farming for aquaculture waste recovery, for boosting and diversification of seafood production, for efficient use of marine space, and to inform decisions regarding the management of a farm and/or an ecosystem. The blueprints for the models are key project deliverables and are available on the project website once accepted.
Nowadays, despite the various technological developments in automated systems, aquaculture farms are far from adapting them in day-to-day operations. Technologies for data collection, data storage, data analysis, decision-making, and visualization have progressed massively in the previous years and have been adapted by multiple vertical industries. The IMPAQT platform aims to bridge this gap for the aquaculture sector as well and provide, as it can be seen at the schema, components for 2 main concepts: a novel and autonomous platform comprising heterogeneous data acquisition systems, and an integrated management system for storing, analyzing, and visualizing collected data to finally enhance decision-making for operations, taking into consideration specific characteristics and requirements of IMTA aquaculture. For the data acquisition systems, the following components comprise the side of the IMPAQT platform architecture: heterogeneous sensor devices, sensors, aimed to determine qualitative levels of water quality conditions, as well as fish and plant mobility; an intelligent and autonomous data acquisition system, and a data aggregation system, an energy management system; remote sensing tools for satellite water quality for IMTA, and crowdsourced datasets for appropriate for farm security and integrity observations. On the other side of the architecture reside the components comprising the integrated management system. This includes the data management system, the data and predictive analytics enabling novel operational capabilities for IMTA systems, such as analyzing fish and seaweed video footage, as well as analyzing time series data for environmental and production-related purposes. The dashboard, the mobile application, and the underlying decision support system facilitating farmers in terms of both automatically optimizing production system. Finally, the methodologies and tools for ensuring fish and seafood quality and safety for consumers are included in the IMS, as well as the IMTA modeling tool producing the models as described in the previous section. We're now going to take a look at how the aforementioned technological systems are going to satisfy the business requirements of an aquaculture site. Moving back to the overall data flows of the system, we're going to study the feeding example. Feeding operations influence in a major way the overall performance of the aquaculture site, since precise feeding is important for the efficient growth of fish populations, while environmental factors are affected by feed loss. So if the goal is to minimize feed loss, the operator should know the amount and the timing of the feeding operation. Information for evaluating fish welfare, such as temperature and oxygen, but also video footage for evaluating fish behavior, is collected through the data acquisition system and transferred to the data management system. From there, data is stored and then distributed to the various applications such as the environmental predictors and the camera behavioral analytics. In the scenario where oxygen is low, the predictors indicate the low oxygen level trends, while the camera analytics identify fish irregular behavior in the cages. These automated observations are reported to the decision support system, which in turn sends messages or alerts to the user regarding low oxygen levels, as well as specific suggestions to proceed with the feeding operation, but in a controlled manner while additional suggestions are given if considered necessary. This whole process can be monitored from the dashboard, which is the main interface of the IMPAQT aquaculture system for the operator. In the monitoring pages, the environmental time series are recorded along with the corresponding predicted trends, as well as the collected camera footage for the operator to observe at any time. Decision making is facilitated at the corresponding pages, which provide relevant statistics visualization, as well as the system suggestions for each specific requirement, such as feeding. The corresponding flows take place for additional business requirements such as harvest, seeding, disease mitigation, grading, environmental footprint, breeding, and infrastructure integrity.
The focus of the work in IMPAQT is around 6 pilot sites across Ireland, Scotland, the Netherlands, Turkey, and China. Our industrial partners are Chamley in Turkey. They operate a large-scale marine sea bass and sea bream farm in Izmir, producing in the region of 7,000 tonnes per year. Through IMPAQT, they're exploring IMTA production practices involving mussels and seaweed, looking at ulva and other species. We work with the North Sea Farms in the Netherlands, who have a site 15 kilometres offshore, who are looking at mussels and saccharina seaweed in an offshore IMTA setting. The Marine Institute's Lehana Pool site in Connemara, Ireland, are exploring IMTA methods, technologies and potentials with salmon, scallops and juvenile lobster, and Delaria and saccharina seaweed species. We work very closely with the freshwater perch farm in County Sligo in Ireland, Keywater Fisheries. They are leading experts in the way regarding IMTA in freshwater and are using innovative split ponds and duckweed for bioremediation at their site. We have SAMS in Scotland, operating a coastal marine site, researching the potential of IMTA of seaweed and oysters in the vicinity of salmon aquaculture at their Oban site. And we've benefited from having the Yellow Sea Fisheries Research Institute in Shandong Province, China on board. They are experts in IMTA, focused on Shangao Bay, where they farm saccharina and gracilaria, along with oysters and scallops, alongside finfish. So these are the IMPAQT pilot sites, where the IMPAQT research focused and are the source of the trials and data for much of the work carried out in the project.
The Marine Institute's Lehana Pool research site in the west of Ireland farms alaria, scallops and lobsters alongside salmon pens. SAMS in the UK are trialling the IMPAQT platform on their IMTA site on the Scottish west coast with seaweed and shellfish. Also in Ireland, experts at Keywater Fisheries are farming perch and growing duckweed in their innovative ramp systems. Researchers at North Sea Farms are practicing IMTA with seaweed and mussels and validating the IMTA model being developed by Deltares. Our industrial partners are Chamley, who grow sea bass, ulva and mussels on their IMTA farms in Turkey. And our Chinese partners in the Yellow Sea Fisheries Research Institute are also demonstrating the added value of the IMPAQT platform in Sangao Bay.